Hi, we're going to start this one for lesson 21, and we're going to keep going with these videos. So lesson 21 is about hypothesis testing for population means when the population standard deviation is unknown. Remember, in lesson 20, we knew the population standard deviation. Now we don't. Because we don't know it, we refer to this as a t-test. So as you can see in huge letters, I put that we don't know the population standard deviation, where we're given the sample standard deviation from the sample that we collected. So again, we have to follow certain parameters. It's a simple random sample, again, to eliminate bias. Population standard deviation is not known, and the sample size is 30 or greater, or it's normally distributed. All right, there's only 3 types of hypotheses that we can make. So the left-tailed can be, the alternative can be less than, or greater than, or not equals. Again, those are the only 3 things you can have in your alternative hypotheses. For simplicity's sake, all we're going to say about our null is that it equals it for right now. Okay? You can also put more direction on these, but for right now, that's all you need to worry about to simplify. So a left-tailed test is a less than, a right-tailed is greater than, and a two-tailed is not equals to. So what information do we need? We're going to need the population mean, and that's the mean again that we use in the hypotheses, the sample mean, which is the mean of the sample size, which is n, and it needs to be equal to or greater than 30, and the sample standard deviation has to be given. Again, we need the level of significance or the level of confidence. All right, so let's look at this on the calculator. Okay, so here's my calculator again. So I'm going to turn it on, and then what I'm going to do, I'm going to hit stat, and I'm going to go over to test. Right under z-test is t-test, and I hit enter. Again, we can put data in, or we can do statistics. Let's hit statistics right fast. And what I can see is I have my population mean, my sample mean, and this is different. You see the SX, that is your sample standard deviation. That's a big deal. That's totally different than what we did in lesson 20. Then we have our sample size and our alternative hypotheses. The great thing to remember about this is if you get confused on the test is the 3 different symbols here, here, and here, those are your alternative choices. They're never going to be anything different, so you can base your hypotheses on those, and that's less that you have to remember. All right, so let's do this. Let's go ahead and do the example that I have on here. All right. And again, remember the rules are the same. Level of significance and level of confidence are very similar. And again, if you can, use my rule of people eat fish from the River Nile, and it helps you with your null hypothesis. Okay? So let's do it this way. It's believed that an average student spends 15 minutes on Facebook every time they visit. A simple random sample of 50 visits has a sample mean of 14.2 minutes with a standard deviation of 4. A professor wants to know if the mean time on Facebook has decreased. Using a 0.5 level of significance, what conclusion can be made on the p-value? All right. We have to make sure it has a simple random sample, which we see right here it does. We have to know if our sample size is greater than 30. And let's see, here it is. Our sample is of 50 visits. So that's definitely greater than 30. And our population standard deviation is unknown. And that's true because I have my sample standard deviation here of 4 minutes. So because of all that is true, I can use a t-test. Okay? And I'm going to keep going through right fast and see what else I need to do. So here's 15 minutes. That's my population mean. And here's my sample mean of 14.2 minutes. Because all I'm doing right now is just gathering my data, and I have a 0.5 level of significance. And the professor wanted to know if it had decreased. So if you're going down, that means it's decreasing, it's less than So it's a left-tailed test. So if you see down here, I have my means. So again, start with that alternative. It will make your life a lot easier. So I have H1 is the mean is less than 15 because it's seeing if it's decreased. If it could be 14, it could be 13. I just want to know that it's lower. My null is that the mean is equal to 15. So I'm going to keep going down, and I've gone ahead and I've dissected what's in the problem. So let's go ahead and put it in our calculator. So I go here, again, stat, over to test, go down to 1 to t-test and hit enter. So I have statistics because I'm not putting any data in. My population mean is 15. My sample mean is 14.2. My sample size is 50. My sample standard deviation, I got confused. I don't want it to be that way, and I messed up in that. So my sample standard deviation is 4. Make sure, that was an easy thing that I did. I just got stuff confused. Make sure, and that's why I like to write down my facts. Even today when I'm solving these problems, I write down all my stuff like that just so I know. My sample size is 50. Do you have to remember everything in this problem? Well, not really, because if you know it's a t-test, go here and it tells you everything you need. So as much as I know you don't want to memorize, and I'm not one of those kind of students as well, know how the calculator can help you with these kind of problems, okay? So I know my sample size is 50, and then I go down to my hypotheses. So this is a less than, so I'm going to go to the one in the middle, hit enter so it blinks at me, and then I'm going to go to calculate and hit enter. All right, so I have a t-test at the top because it tells me the correct test that I did. Mean is less than 15. Again, that's the same as my alternative. And then my t test statistic equals negative 1.4142. My p-value is what I'm looking for. P equals 0.0818, which is great because that's what I was looking for. So if I go down here and I put it in and I put right here, this is what I'm looking at, okay? So is 0.0818, is that less than 0.05? And that's not a true statement. But because it's greater than that, I fail to reject the null. Because I fail to reject the null, that means the null is true, so I'm keeping it. So I went down here and I showed you what I did. If I fail to reject my null because my p is greater than my level of significance or my fish or my alpha, I can say that my mean equals 15 minutes. So because we test everything on the alternative, the conclusion is that there's not enough evidence to conclude that the mean time on Facebook is less than 15 minutes. That's how you complete these problems. If you were given a data set that you had to enter into L1, like some of the problems in Lesson 21, remember, you just go to Stats, hit 1, and that's where you put your data in. You want to put it in L1. And then to run it, you go Stats, Test, down to t-test, and then you click on the data and hit enter. And then from here, you put your population mean, scroll down, and then you put your hypotheses. Because what list 1 and frequency is doing is giving you all the information from the sample as opposed to you putting it in there. I hope this one helped, and I'm going to keep going, and let me know if you have questions.